Okay, so this is going to finish up our last page as far as notes, page 10, which just basically summarizes everything. If you're tired of writing notes and you just finished writing the notes for page 13, go ahead and start some of the stuff on page 14 and 15, or do some of the quizzes. This will help you because it kind of puts everything together in one spot. So if you are up for it, this will kind of help you with everything being in one spot. All right, so kind of compare and contrast. So ionic, first of all, remember, is when we're talking about a transfer of electrons. One is giving the electrons to the other, right? So we have a metal and a nonmetal, and the metal is actually giving its electrons to the nonmetal. Whereas covalent is a sharing of electrons, and it's going to be between two nonmetals. Ionic things like salt and different things like that have high melting points. These bonds are very strong, so they have high melting points and high boiling points, and that's because those bonds are strong. Whereas covalent things like sugar have low melting points and low boiling points. And that's just because they're a weaker bond. Ionic create charged particles. Right? We end up with a positive and a negative ion. Whereas covalent don't have any charged particles because they're just being shared. So because of these charged particles, ionic will conduct electricity when it's a liquid or dissolved in water. So salt, for example. If we just stuck a probe into salt dry, it's not going to conduct electricity. But if we put salt in water, it's an electrolyte. That's what we drink when we drink Gatorade, electrolytes. They conduct electricity. Because covalent is not charged, and there aren't these positive and negative ions, they do not conduct. So sugar water will not conduct, but salt water will. Ionic are hard solids, whereas covalent are soft. Things with carbon and stuff in them are soft covalent ones, butters, greases, things like that. Okay, so these are soft solids. When we talk about ionic, we have brackets and arrows and charges, whereas in covalent, we don't have those things. We have diatomic molecules, and we do have polar and nonpolar molecules. So two different types of covalent. So to just summarize an example, if we have sodium with its 1 valence electron, we have chlorine with its 7. The sodium is going to give its electron to the chlorine. So that's going to give us Na with a +1 charge because it gave away its negative. We have chlorine with the 7 of its own, the 1 that it gained. So because it gained an electron, it's -1. And we end up with NaCl, which is sodium chloride, and no prefixes. Whereas in covalent, if I have, let's say, carbon and hydrogen, I have carbon with 1, 2, 3, 4. I have hydrogen with 1, hydrogen with 1, hydrogen with 1, hydrogen with 1. They're going to share those electrons. Carbon has 4 of its own, 4 that it's sharing, so it's happy. Hydrogen has its 2. So we use these circles to show that it's sharing. There aren't any charges, there aren't any brackets. Our formula would be CH4, and it would be carbon tetrahydride, because now we do use prefixes. And then as far as our polar and nonpolar, If we look up what their electronegativities are, hydrogen we know is 2.2. Carbon is, I think, 2.6. Yeah, 2.6. Carbon is 2.6. So carbon is a little bit more electronegative. So each one of these that's shared is going to be pulled a little bit in by the carbon and not shared evenly. So each one of these hydrogens is going to have a little tiny positive, and the carbon's going to have a little tiny negative. So the carbon-hydrogen bond would be polar. It has a difference of 0.4. So not very polar. Remember we had 1 and 0.8 in the last ones we did, but a little bit polar. Okay. All right, so then the last thing that you guys are going to do in this notebook is page 14 and 15. So just be careful and make sure you answer all of the questions. So what type of elements most commonly form covalent compounds? What are some ways you can determine if two elements will form an ionic compound? So you got 2 questions there. Describe how the electron sharing in an oxygen molecule is different from the sharing in carbon dioxide. So the sharing part and how their sharing is different, think about what we just did today with the polar and nonpolar and the electronegativity. Show the creation of methane using an electron dot diagram. Methane, if you look up the formula, is CH4. So I want you to go ahead and draw electron dot for that. How are covalent and ionic similar? How are they different? Okay, so give a couple ways that they're similar, a couple ways that they're different. Think of one ionic compound and one covalent compound that you've experienced in your life and compare and contrast their properties. Okay, so I talked about a couple of them when we were just sharing. Page 15. For each of the following pairs of elements, give the formula. So when those come together, what's it going to be? So this is basically like page 11 and 12 that you did. The name for the compound. So silicon and bromine, what would it be when they're combined? And then the electron dot diagram. You don't have to do anything as far as polar for this one. Okay, you don't have to do anything for polar for these A, B, and C. Okay. Give the formula for each compound below. So you just have to write what they are once you create the formula for them. So think about, are they metal and nonmetal? Okay. And then the last one, this is the only one that goes with what we did today. Which of the following is the most polar? So it'll be just like what we did on page 13. Okay, and then there's a quizzes just on general bonding stuff for you to answer. Okay, so that's all the stuff. You have Thursday and Friday to do all of it. You have to hand in your notebook at the end of the day Friday. If you don't get your quizzes done, you can do it over the weekend. Email me, of course, if you're stuck on stuff or you're not getting things done as quick as you need. If you need more time, that's fine. Okay? All right, good luck, guys.